Now we are going to welcome our next speaker, Sir Nadeem Sarwar. Nadeem Sarwar is a senior member of IEEE and works as an assistant professor at the Department of Computer Science, Baria University of Lahore, Pakistan. He has 12 years of teaching and research experiences. He has published more than 65 international and national journal conference publications in the last 5 years. Sir, I'd request to present your presentation and share your.
Is it visible?
Yes, sir, we can.
Is it visible? Okay, that's
Can
good.
see. Sir, can you just try to move?
Okay.
Yeah, we can see your cursor, sir.
Yeah. And in unsupervised learning, supervised learning is a type of machine learning model that identify patterns and structures within an unlabeled data. So email topic modeling, same example, which was shown on the last slide. A large collection of emails you may want to organize by subject matter. During training session, learn the distribution that generate the structure within the data. And inference, assign new email to the cluster where they have to the highest probability of belongings. And in reinforcement learning, interaction, reward and penalty, and policy update. And an interaction agent interact with the environments by choosing actions from its current policy. Like that, a self-driving car decides to take a left or right based on its current strategy and current state of the road. And in reward penalty, after each action, agent receives a reward penalty which reflects the success of the action. Like that, if the car safely navigate traffic or obey rules, it's success. Otherwise, not. And in policy update, agent update the policy based on feedback received, aiming to maximize the total reward over the time. And for example, based on the reward penalty, the received car adjusts its driving policy. Actions with positive rewards will be repeated and negative rewards will be avoided. And in the fourth form, the shallow and deep models. Models with limited layers and capable of capturing only linear and simple nonlinear relationships are called shallow models. Models with many layers and capable of capturing complex hierarchical patterns are called deep models. And this is the diagram where you can easily understand the classification of the algorithms. In the AI, we can classify machine learning into three classes: supervised, unsupervised, and reinforcement learning. And same is the supervised learning classify in discriminative models and generative models. And then discriminative models, again, shallow models and deep models. And shallow models further classify in logistic regression using these algorithms used for shallow models, and CNN and RNN used for deep models. And in generative models, here is our specific topic. So here we also classify two broad categories: shallow models and deep models. And in shallow models, Naive-Bayes is the best for the to implement generative models. And in deep models, we use conditional and variational autoencoders. And like that, in unsupervised learning, when we use generative models, we use deep models, then we use autoencoders. And in shallow model, we use Gaussian mixture models. And now we have moved to further topic. We are moving on GPT, GN, and diffusion models. So the definition of generative AI refer to the set of artificial intelligence methodologies that can produce novel content that resembles the training data they were exposed to. The content could be anything, spanning from synthesizing text, generating code, realistic images, music, and more. Here is the example. Like that, we take input V1, V2, and V3, and when we will pass to the generative speech model, and this is the final output in the form of one voice.
Sorry to interrupt.
Again, not visible.
Yeah, I think so. We are stuck in the introduction slide.
Oh shit! I think maybe we are facing internet issue. That's why.
Sir, we can reshare. You can reshare it now, please.
I can reshare it. Now visible?
Yeah, sir, you can see generative AI.
Yes, and now I have changed my slide.
Slide. Yeah.
How generative AI works? The system generates text or images using its previously built model of the statistical distribution of tokens, like chunks of words, punctuations, marks, and pixels, created from its very large training set. Here is the data set, and we uh, divide it into two categories: training dataset and testing dataset. And training dataset will be used to build a system, and testing dataset will be used to check the correctness of the system. And here is the document which is generated after the using the generative AI model. After that, it might make mistakes or hallucinate based on the limitations of its process, but the output still might look like what you wanted. Ted Chiang analogy, unreliable photocopier, or a blurry image. Depends on the your desired output which you want to generate. And which is the motivation to use generative pre-trained transformer models? We are facing some issues. Now we are discussing issues with CNN, RNN, and LSTM. So conventional neural networks are good at local feature extraction and struggle to understand long-range dependencies in the data. But CNN do not have a mechanism to understand the order of the elements, making it harder for problems involving text and time series data. And the RNN, especially LSTM, can handle long-range dependencies due to their ability to process data sequentially. But as the sequences get longer, they struggle from the vanishing gradient problems. CNN, RNN, LSTMs are suitable for specific data types and are not efficient at handling multimodal inputs. After that, which is the motivation? A new architecture called a transformer is proposed by scientists from the Google, which is avoid the recurrent connections altogether by relying on an operation known as attention. And this architecture also takes care of sequential nature of inputs by using positional embeddings. Here is the paper. I have mentioned the link, which is published by a Google scholar. Now, let's take an example sentence like Alice, who has a black cat, loves going to the park. When the model is pre-processing the word loves, attention mechanism allow it to associate it with Alice. At each word, attention mechanism allows to look at words. The other oppositions in the input sequence is to better encode the word and the current position. When we process it at each input position, calculate query, key, and value vectors, a linear transformation of embeddings using learned weight matrices. Number two, compute dot product between each query and all the keys in the input sequence. Number three, compute a weighted sum of all values vectors using attention weights as coefficients, which is mentioned in the paper. I have mentioned the link under in footer. After that, which architecture we follow? 6 encoder layers are stacked and 6 decoder layers are stacked, and positional embeddings and mass attention encoder decoder attentions are the part of the architecture. And what was that advantages of this architecture? Better long range connections, easier to parallelize, can make the networks much deeper than RNNs. Then a generative pre-trained transformer is the kind of the transformers model developed by the OpenAI for natural language processing tasks. What is the generative? Generative refer to the model's ability to generate text, and pre-trained refer to the model training process consisting of two stages. Two stages means pre-training and fine-tuning. And pre-training model is trained on the large corpus of text data, where the objective is to predict next word in a sentence. And fine-tuning, once the model is pre-trained, the model can be fine-tuned on the specific task with the task-specific datasets with supervised learning. And then here is the stats where we use some datasets, dataset 1, 2, 3, 4, and 5, and the table 2.2 dataset shows the details of the dataset with the quantity, weights, and the epochs. And right side graph is shown the accuracy, shows the number of datasets, population of the dataset. Last one, you see ChatGPT 3 used 175 billion samples, mean tokens, which used to train. And the ChatGPT 3 unreasonable effectiveness. And section 1, you see zero shot, then open shot, then few shots, then fine tunings. And the takeaways regarding comprehension dataset containing over 650K questions, answer, evidence, triples. So it is a very large dataset which is used by the ChatGPT. And what is the LLM landscapes? In LLM landscape encoder models, these models map input sequence to vector representation useful for extracting features called BERT. Then decoder models, these models generates an output sequence from a fixed length input vectors useful for generation, text, images, etc. And encoder decoder models, these models are the combination of both encoders and decoders. Encoder is the responsible for mapping input into the vector, and decoder generates output sequence from the vector. BERT model, it is the advanced model. So generative pre-trained transformer, chain of the thought prompting. Chain of the thought prompting is a technique that enables LLM to complex reasoning generations, a chain of thoughts, a series of intermediate reasoning steps. You can see the example. Number 1, standard prompting, which was an old technique where we enter a question. Question 1, Roger has 5 tennis balls. He buy two more cans of the tennis balls. Each can has 3 tennis balls. How many tennis balls does the have now? So system answer is 11. Then again we asked to the system, the cafeteria had 23 apples. If they use 20 to make lunch and bought 6 more, how many apples do they have? So system response is 27, but that is wrong. So when we use advanced technique, chain of thought prompting, we collect we receive the answer in detail. Like first one, we check Roger started with 5 balls, 2 cans of 3 tennis balls, each is 6 tennis balls. 5 plus 6 is equal to 11. The answer is 11. So this technique provide us the detailed answer to check, verify, and understandable. Now alignment, RLHF, reinforcement learning through human feedback, is a technique that allows models to learn directly from human feedback, like prompting, which was discussed on the previous slide, without the need for the labeled data. It does not need to require labeled data. Due to the nature of the training data, being scraped from the internet contains a lot of misinformation, conspiracy theories. The models must be further polished, aligned using RLHF to make it user appropriate. Now, generative adversarial networks. Imagine you have a bunch of cat images and you want to machine learning model to create similar images. This is exactly what a GAN does. Generator token takes in random numbers as input and generate the images of the interest. The indiscriminator takes both the images from the generator and the real images from the data and spots the difference between them. Both the generator and discriminators are trained together, and over the duration of training, the generator gets better at creating images which looks real, and the discriminators gets better at spotting fakes. And in adversarial objects, these two networks are pitted against each other, where the generator creates more realistic synthetic images to fool the discriminator, while the discriminator network tries to get better at detecting fake images. This back and forth strategy forces both the networks to improve until the generator can create highly realistic synthetic images that is indistinguishable from the real images. And what is the diffusion model? Diffusion models are another class of the generative models which work by adding noise to the images in the training data by a process called forward diffusion process, and then reversing the process to recover the original images using reverse diffusion. These models can be trained on large unlabeled data sets in an unsupervised manner. And the stable diffusion is the text to image model. A stable diffusion model has four important elements. Number one, diffusion probabilistic model. Number two, unit architecture. Number three, latent text encoding. And number four, classifier free fluidance. Here is the example of Del E. Del E, we write text, a 3D render of an astronaut walking in green desert. So it generates these figures as per our query. So that is very near to the real diagrams. And here's the example too. We add a text, gold bars chilling a beach. So it generates these diagrams. These are very near to our query. And here is the Majesty boat example. We same query put in this application, and this generate these diagrams. And again we check with the new query. Imagine a small seed planted in the ground. It's sprouted, grows into the scaling, then a small tree, and finally a large robust tree. Each year it sprouts new branches, leaves, and sometimes fruits. All that from that the small seed. This is how your investments grow with compounding. It branches out, producing more and more, just like a tree. So you look like an image, or it produce a plant which differ with the other plants. So this is a chat GPT. We input a query. Given this image, can you create a nice GIF out of it by adding a motion effect? So that ChatGPT reply, sure, I can help with that. Could you please specify that the type of motion effects you would like to apply to the image? For example, are you interested in a zoom in or out effect, a sliding effect, or a rotation effect, or something else? So we select a zoom effect, please. So ChatGPT reply, I have created a GIF with a zoom in effect. You can download it using it like a below link. So this is a new project, NER for optimization, named entity recognition for optimization modeling from natural language. So envision automated modeling assistant to turn a natural language into the optimization. Right side the diagram shows that we put a text to the software, and the software detect the name entities from the paragraph, which is the input. We put in as input. Necessary building blocks, finding key pieces of the information relevant to the optimization. So NER for optimization project scope is the extracting optimization related to information such as the objectives, constraints, and the variables from the free from natural language text. So correcting semantic parses with natural language through dynamic schemas encoding. There are several semantic and syntactic challenges in the converting natural language text to the SQL queries. So in this paper, authors approach semantic parse corrections using natural language feedback. With just one turn of the correction, authors saw an improvement of the accuracy up to 26%. They also show that a base T5 model can correct the errors of a T5 large model in a zero-shot cross parser setting. So which are the emerging trends of generative AI? Major breakthroughs in deep learning architectures like transformers and generative adversarial networks, and availability of the massive datasets and GPU, TPU computations. Number three, new advances in techniques like RLHF prompting made it much easy to align these models. Low barrier of entry due to the initiative and user-friendly interfaces and strong open source ecosystem. Generative AI holds potential to create photos, realistic images, human-like speech, and text and generate working code from the natural language descriptions, which is not possible until recently. So these are the things to keep in mind. Number one, lack of consistency. LLM tend to produce wildly different answers when the same question is asked multiple times. And bias, as the models are trained on data scraped from the internet, they might have inherited the biases present in the training data. And interpretability, it's difficult to understand why a particular response or content is generated, making it very challenging for use cases where explainability is inherently required. And number four, real-time knowledge. As the models are trained on a fixed dataset at a particular point in time, they lack information, changes that occurred after that point. Number 5, memory. Even though these models are getting good with context, lens that can be spotted having an efficient memory, remembering in the important details of conversations over a long period of time is still a challenging task. And number 6 is engineering challenges. Operating these semi-non-deterministic models, especially in a multimodal setting, including voice, text, images, at a scale remains a significant challenge. And these things are necessary to keep in mind. And these things are the potentials of generative AI. Number 1, low resource languages. Ability to understand, generate any language, especially low resource ones, could help study languages and historical documents in general. And number 2, inclusion and accessibility. Avatars proficient in sign languages, high precision caption generation, etc. would increase accessibility for all people. And number 3, personalized content generation, like video games, music, movies can be created that cater to users and individual interest at scale. And number 4, AI tutors. Imagine a world where you can conjure up to a tutor to teach you any skill you would like to learn at your own pace.
Sorry to interrupt. We have less time in hand.
Yeah, this is the last line. Last line. I'm closing my slide.
Thank you.
And last point is the intelligent assistant, and number 6, the accelerating scientific discovery. So it is a huge applications available, and many researchers are working in there. And if anyone interested to work with me, and here is my biography, and you can also find me on my LinkedIn and my university profile. And I always welcome to collaborate and work with other researchers. Thank you.
Thank you, sir. Thank you for your really interesting and valuable speech. Do you have any questions? Okay, we can ask sir through the email or in LinkedIn, I think.
Okay, sure.
Thank you.
Okay, thank you.